right, welcome to our final video tutorial on Python for data analysis. This week, maybe we won't dive too deeply into the data analysis aspect because we will be looking at OOP concepts such as encapsulation, inheritance, and polymorphism, um, which you don't really need. You can get away with what we've covered so far, but we'll just go through these examples or these concepts today with a few examples that will be useful for you in future. Okay, so the first concept we will look at is encapsulation, um, also known as private attributes. So here's an example for us. Let's say we want to define a user for our, I don't know, some application. We have a constructor, um, self, and each user has a username and a password. So we define the username like we've seen already. Self.username equals username. And this can be public. This can be a public attribute. But if you want to keep, for example, the password private, we define it using to begin with two underscores at the beginning. So underscore password equals password, and we'll see how this makes it private in a second. Okay. So here's a method to check password without exposing it. Df check, as usual, code with me. Self password and return self dot underscore password equals our password. Okay, so when we run this, you will see it keeps our password private. Okay, another method to change password securely. Okay, I should have corrected this typo up here. Check. Change. Okay. Change password. Self. Our old password and our new password. So this function will let us change our password securely. So if self dot check password old pass self dot password equals new pass, and we can print password changed successfully. Else print incorrect password. Okay, so let's run this now. I'm gonna create a user. Uh, some user equals from this class user, and this user has a username and a password. So let's say username is Bob and password is secret123. Okay, print user dot username. Okay, so we can print the username. We've created this class, then we've created an object based on this class. The user's name is Bob, password is secret123. We can easily access this public attribute. Okay, we can print that. If we tried to print the password, if we tried to print that, we would get an error. Object has no attribute password. So this is private. The two underscores have made it private. So we can't easily just access that and expose that. So this is where these private attributes are useful. So I will comment this out. Okay. So let's check our password. User to check password. Secret123. True. Okay. Um, so if we were to try something else, it will just give us false. It doesn't expose the password. It just tells us whether this is correct or not. And we can change the password. User dot change password. Okay, the old password is secret123. The new password is new secret. Password changed successfully. Okay, so this is what the benefit of private attributes. It keeps things that you want hidden private. Okay, the next concept, inheritance, which is we've seen a little bit of how we can use this before, but with inheritance, you have, let's call child classes can inherit properties and methods from parent classes. Okay, so let's create one class. I call it a vehicle. Constructor. A vehicle has a brand and maybe call it the speed at which it moves. Maybe top speed or average speed. Self.brand. Okay, these attributes. Brand. self.speed equals speed. Okay. So method available to all vehicles. TEF move. So all vehicles can move, and we can print the brand is moving at speed miles per hour. Okay, so that's our class. Um, so we can create another, let's call this is our parent class. Let's say this is a new child class. So let's call this class car. A car is a type of vehicle, so it will inherit the properties and the methods from vehicle. Okay, init self brand speed doors. So it's going to inherit the properties from the vehicle, and it's going to call the parent class constructor, which it does using the super keyword. So super dot init brand speed. So it has inherited from vehicle this, and it can also have its own attributes. Self.doors equals doors. And it can have method specific to this car class. Def honk self, and it's just going to make a sound. Print beep beep. Okay. So this is the parent, and this is the child. The parent has inherited the properties from, sorry, the child has inherited the properties from the parent, and it has its own attributes and methods that it can incorporate. So let us have a go and try to define, say, bicycle. Try to complete this code similar to this and add maybe one method specific. So I will pause it now and have a go at completing this very simply. Okay, so here's a completed bicycle class. Just like car, it has inherited from parent, the brand and the speed, but its own things specific to it are its gears and the noise it makes when you ring the bell. So this is a example of inheritance, and let's create some objects. So this is one car. um, say it's a car, it's a Toyota. 60 miles per hour top speed. It has four doors and some bicycle instance of the bicycle class. um, I'm calling this super feats. Super feats is the brand. Top speed 15 miles per hour. And how many gears does it have? 21. Okay. So car, a car can move. It has inherited this from the parent, the move, but it can also call its own functions. So car dot honk beep beep. And you can do the same for the bike dot move. Okay, super feats is moving at, which is inherited from this. And bike dot uh, ring bell, ring ring. Okay, so this is why inheritance is useful. If you need to create objects that are somewhat related, you can define a parent class that contains, the common properties and methods that these child classes will use. The child class will inherit from the parent class and then add their own. So this allows you to avoid um, repeating code, and you can just inherit inherit the properties and methods from parent classes. Okay, so the next concept we will look at is polymorphism. So here, you can have methods with the same name, but different implementations. So here's an example. Um, let's define this shape class. So we're going to define the area of a shape, um, called pass. So this is a placeholder. Uh, you know, child classes will implement this. So this here, the shape, this is a parent class. So we're going to do some inheritance and polymorphism in this example. So here's a child class. Let's say class rectangle. And of course, it's going to inherit from the parent class shape. So our constructor in init self width height self dot width equals width self dot height equals height, and we can override this area method from the parent class to get area for rectangles. So df area self, and the area will be the width times the height. So self dot width times self dot height. Okay. So this is one child class. Um, here, have a go. Have a go now yourself at another child class. In this case, let's circle and finish this up and see if you can complete this. Complete this like we did for the rectangle. Okay, I will pause now. Okay, so you should have something like this. Um, this is another child class with a different implementation of the area method. So you can see the circle. Properties of a circle is a radius. Um, its own area would be pi r squared, which we have defined here. So even though we inherit area from the parent, we have two different implementations depending on the child. So if so, let's check this. Shapes. Let's create an example, a list of shapes. We have a rectangle. Let's say width and height, and another shape is a circle, radius 7. And let's go through each shape in the list and print out its area. So for shape in shapes, so we're going to iterate through this list. Print area is shape dot area. So each shape, each implementation uses its own, or each child class uses its own implementation of the area method, which it's inherited from the parent, but we allowed each child class to implement this. Okay, so this is polymorphism. Polymorphism appear in different ways. You have the same method name, but different child classes can implement the same method in different ways that are going to be specific to them. Okay, okay. So um, let us have move on to the next concept: class variables versus instance variables. So let's create this class called employee, which we know how to do this now. We're going to call the company Tech Corp. And this is a class variable, and it will be shared by all instances. So now we can define this constructor. So an employee has a name, a salary. Of course, they could have ID, they could have the department they work in, etc., etc. But we will just define name and salary. So these attributes, self.name equals name, self.salary equals salary. And this, like these will be instance variables, and this will be unique to each instance. Okay, so let us create two employee instances. Okay, so employee one, an instance of the employee class, name of John, salary 50,000. A second employee, employee two, again from the employee class, Jane, salary of 60,000. Okay, so if we print employee one dot company and print employee two dot company, they both belong to TechCore because this is a class variable. It is shared by all the instances. So however many instances of the employee class you create, they will all have this value for the company variable. So it's shared by all instances. And, you know, employee one dot name is John. Employee two dot name is Jane. But their company is TechCorp. So it's the same. If you were to change the class variable, it will affect all the instances. So if we say the employee class dot company is now, they changed their name, they've merged, you know, with someone else, and they had now New Tech Corp. If you print employee one company and print employee2 company. Okay, I forgot to close the brackets. Now all the instances are affected. So these are class variables versus instance variables. The class variables, regardless of how many instances you create, they will all have this class variable. It will be shared by all instances. Okay. Okay. So then now we can look at static methods and class methods. So let's create an example here. Class calculator. Static methods and class methods. Static methods, you can call the method without creating an instance. So if we have this calculator class, static method def a b, and what that does, oh sorry, def add, so add a and b, and we're going to return a plus b. Let's create another static method, multiply a and b, and it's going to return a times b. Okay. So here we can just call this directly. No need to create instance. Okay, so I could just say calculator dot add 5 3. Okay, calculator dot multiply 5 3 15. I didn't have to do calc equals calculator. I didn't have to do any of this like we've been doing ahead. I can just call the methods directly. So these are static methods. You don't need to create an instance. You can just call them directly. So let's here look at the class methods now. So let's create a new class. Call this product. Say tax rate equals 0.08. Let's say 8% tax rate again, and this is a class variable. So now this is our constructor self name price. Self.name equals name. self.price equals price. So let's define our class method. Um, at class method. We're going to define a method that has access to the class variables. So let's define a method to change the tax rate on a product. Change tax rate on a product. We will use the CLS keyword to access the class variable. So CLS the tax rate equals new rate. So we can change this class variable using this class method. And this is an instance method that uses the class variable. So define a method called total price self, and it's going to return the original price plus the extra because of the tax rate. Self dot price times 1 plus product dot tax rate. Okay, so let's create an item. It's a product. The product is a laptop, and the price is 1,000 euros. So item the total price. Okay, product. Okay, total price is a method. Okay, all right, let's move that there. Problem with the indentation. Okay, it was essentially outside of the class. Okay, so this is your product. You have products, you have tax rates, and your class method will access this class variable. And we can change, let's say we can change the tax rate. So product dot change tax rate 0.1. So no longer 8%, it's 10% now. Let me put this in a new cell. Okay. Product has now attribute change tax rate. Okay. Okay. Let's leave this in here. Okay. So this, let's move it Okay, this is a class method. It's a method on its own, not inside the init. So this should work. Okay, yes. So with the static method, you don't have to create an instance. We can just use the method directly. Use the class name and then call the method directly. We don't have to create an instance like you create here. We don't have to create these instances. We can just call them directly. With the class method, we can access the class variable using this class method. So if we want to change the tags, we can just call this and it could change the tags for us. But we access this class variable using this CLS keyword. Okay. Okay, finally, we will have a look at special methods. So we can define custom behaviors for operators. So let's have a class called point. Define the constructor self. This is a point x and y coordinates, and of course self.x equals x, self.y equals y. Okay, so here we can define how the object is printed. Let's define how object is printed. We're going to use the __str keyword self, and we are going to return f point self.x self.y. So this str keyword will give us a string representation of our object. Okay. We can also define behavior for the plus operator. So when we use a plus operator, it will do something else. Some places you'll see this as operator overloading. Let's have a look. So self other, and we're going to return point self.x plus other dot x self.y plus other dot y. Okay, so here let's create one point p1. So this is a point x2 y3. Let's create p2. Point p2 x is 4, y is 5. Print p1. So print p1. It 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 gives us a way of defining this in a nice user-friendly way, friendly string representation of our point. So when we call print, this gets called, and whatever we want here is displayed. Okay, and we can say p3 equals p1 plus p2, and we can print p3. So this plus, what it now does is uses this behavior. So the add now, specifically, it adds the first x to the other x, and then the first y to the other y, and gives you the output there. So we've defined this these special methods, not something that you will likely be using regularly, but it's good to know. So we have covered the first three things that are the most important. Encapsulation, so private attributes, if you don't want attributes to be seen, the underscore before the attribute name is useful. Inheritance, also quite useful. Um, so you can have child classes inherit properties from parent classes, properties and methods. So if this is a parent class, vehicle, it has its own attributes, it has its own method. You can create a child class that inherits from the parent. It still has access to everything the parent has, but now it has its own specific attributes and its own specific methods. Same here with this example. Access to the parent class, but its own specific attributes and its own specific method. So this is quite useful, allows you to create different types of objects without reusing, without rewriting code. So you can just have a parent class and then reuse that parent class and inherit from the parent class. And finally, polymorphism. So here you can have the same method name but different implementations. So again, you have your parent class that has a method of its own and a child class. A child class inherits from the parent class, but its own area function will return something, and a different child class, which is inheriting from the same class, has its own area function, but it's returning something else. So these are the three key things that we should know or three additional things we should know about OOP: encapsulation, inheritance, polymorphism, and then everything else. Um, these other things are also useful to know. So class variables versus instance variables. Um, every instance you create will have will share the same class variable. And then finally, static methods and class methods. Okay, so um, this is the end of the tutorials. There is no real exercise, but what I want you to do is to go through this to-do list application that uses the OOP concepts that we've covered, and well, try to re-implement it. So don't just copy and paste. Try to actually type it out and see what it's doing. And then once you've done that, play around with the application. See if you can modify it. So for example, maybe you want to remove a task. Okay, you don't want that task anymore. Or maybe you want to remove a task if it's completed. See if you can modify it to that. Or if you already have a task in the list, for example, buy groceries, medium priority, maybe you want to change this priority so it's a high priority task. So see how you can play around with this and um, make whatever changes you like. Some examples of the changes you make I've given here. So this is all for the Python tutorial series. Again, if you have to rewatch some of the videos, rewatch them, code along with them, and good luck with your programming journey.